Hello, it's me, Luigi, and welcome to Lego Luigi Explores the Human Body. Today, we're gonna look at the urinary system. Let's go! Now, I'ma know what you're thinking. Luigi, why start out the series by talking about the urinary system? Well, let's just say I have my reasoning. And here to help me is my friend Yoshi. Hello. Together, we're gonna take a look at the urinary system and what it does. Okay, so what is the urinary system? Great question. Let's see.
The urinary system is one of the ways our bodies get rid of waste. It does this by using the kidneys, ureters, bladder, and urethra.
And how does it work? Let's take a look. Is that my cue? Yes, Mario. Okie dokie. This watermelon is made up of over 90% water. They don't call them watermelons for nothing. Hey, Yoshi, that was for the video. Sorry, I was hungry and that watermelon looked delicious. Oh, by the way, where did your cap go, Mario? Oh, I probably dropped it on the way over here. Okay, now let's get back on topic. We all need lots of water every day to keep our bodies running smoothly. Just like that watermelon, over 90% of plasma, the liquid part of our blood, is made of water. Wow, that's a lot of water. But tell me, what does any of this have to do with the urinary system? I'm glad you asked. Water makes up most of our blood volume, and sometimes we need to get rid of extra water. That's what the urinary system is for.
First, blood travels to the kidneys where it gets filtered. Anything the body doesn't want, such as extra water, sodium, and urea, is taken out of the blood while everything else stays in.
And they call them kidneys because they look like kidney beans, right? No, it's the other way around. Every day, your kidneys filter 200 liters of blood, which is just under 53 gallons. That's amazing. So what is urea? I've never heard of that. Oh, urea is just a chemical the liver makes by combining carbon dioxide and ammonia, both of which are byproducts of chemical reactions that take place in the body. Ammonia is very toxic, so it has to be turned into urea or uric acid, depending on what kind of animal you are. Man, our bodies are clever.
Anyway, once all the extra stuff your body doesn't want is taken out of the blood by the kidneys, then it goes through the ureters into the bladder, which is like a storage tank for urine.
Urine what? No, I said the urine. That's a mixture of all the stuff the kidneys take out of your blood. Oh. As the bladder fills up with urine, the walls of the bladder stretch, sending a message to your brain that says, I have to go to the bathroom. That's right. That's when your body says you need to go to the bathroom. No, I need to go to the bathroom. Oh, okay, go ahead. Thank you.
Now, when the time is right, muscle fibers in the walls of the bladder push the urine out of the bladder into the urethra, which is like a tube that leads outside of the body. This urethra is pretty short, so it must be a female urethra. The male urethra is much longer, and once Yoshi gets back, I'll explain why.
Many minutes later.
Shouldn't he be back by now? Yeah, I don't know why it's taken him so long. Why don't we just go on without him? Okay, this is gonna be on the internet after all. Now where were we? You were going to explain why the male urethra is so long. Alright, the male urethra is so long because it has more than just one job. We'll see what else it does in a later episode, but for now, let's just say that it lets us paisanos stand up when we go to the bathroom. And if you're watching, Yoshi, that's what the winner is for. Well, I guess that does it for today's episode. Wait, shouldn't we explain what makes urine yellow? Oh, good idea, Mario. Urine is yellow because of a chemical called urobilin, which is made from the breakdown of red blood cells. You can tell if you've had enough water from the color of your urine. If it's a light yellow, you're okay. If it's a dark yellow, you need more water. Okie dokie, that should be enough for this episode. Yeah, I'ma think you're right. Thanks for watching, everybody. Make sure to like and subscribe to Luppet Central for more videos of me and Yoshi. The links to the research sources for this episode are in the description below. See you next time! I wonder what's taking Yoshi so long to get back. Hello, it's me, Luigi, and welcome to Lego Luigi Explores the Human Body. Today, we're gonna look at the nervous system.
Let me guess, is that the body system that deals with being nervous?
Good guess. The nervous system is a system that monitors and controls all of the other systems in our bodies. Would you like to see how it works?
Sure.
Okay, let's go! The nervous system is made up of three main parts: the brain, the spinal cord, and a complex network of nerves. The brain and the spinal cord make up what we call the central nervous system, while the nerves that branch all throughout the body make up the peripheral nervous system. But no matter where they are, all parts of the nervous system are made of a special kind of tissue, known as nervous tissue.
Wait a minute. I have tissues inside of me?
Oh, when we talk about the body, a tissue means a group of cells and the stuff surrounding them. The organs in our bodies are made of different kinds of tissues, but we'll just be focusing on nervous tissue for now.
Oh, that makes sense.
Great. Now will you do me a favor and go get a dry bone shell?
Okay, but where can I find one?
I'm sure you can get one from the castle at the end of this world.
Oh, thanks. I'll be back when I find it.
Well, that should keep her busy for a while. Now, if you've ever used a computer, which I'm assuming you have since you're watching this, you should be familiar with how it works. The nervous system works in a very similar manner to a computer. Hey Luigi, where are the Joy-Con controllers? Oh wait, never mind, I found them. Okay, so let's compare the nervous system to a computer. We can begin by pointing out that they both receive inputs, process it, and output a result. In the case of the body, the input is something that happens to a part of the body or is perceived with the senses. When an input is received, sensory nerves send signals through the spinal cord all the way up to the brain where the signals are processed. Then the brain sends signals back to wherever they're needed to tell the body to do something. When you think about it, the only difference is that your brain and nerves never turn off like a computer can. In fact, they work even harder when you're asleep. Hey Luigi, the internet is out. Try resetting the router. Okay, thank you. Now let's take a closer look at how our nerves send signals from one place to another. Remember before when we talked about nervous tissue? Well, this is a diagram of a single nerve cell, otherwise known as a neuron. Some neurons are really short, while others can be as long as your leg, and they're protected by special cells called glial cells. This is important because our neurons can't replace themselves, so it's a good thing they live so long. The neuron receives electrochemical signals through its dendrites and sends them through its axon, which makes up most of its length. The place where two neurons meet is called a synapse, and when the signal reaches the end of an axon, it crosses the synapse to get to another neuron, where it sends the signal through its axon to another neuron, and so on.
Okay, here you go.
Oh, thank you. What's your name?
Oh, you can just call me Jordan.
Okay, thank you, Jordan.
You're welcome. It wasn't easy though. I had to cross a spiky path on the way.
Ouch.
Ouch is right. I did my best to maneuver around them, but I accidentally stepped on one, which made me jump. Fortunately, there was a question block right above me with an invincibility star, so I was safely able to cross.
You know, you actually bring up a really good point. Most things we do require our brains to process incoming signals, while some, like moving away from something sharp and painful, don't need to be processed by the brain. These are called the reflexes, and they're most often used in instances where speed is vital, as the brain would slow them down, but they eventually reach the brain to be processed further.
Hey, that reminds me of the time I thought I had a brain drain. I could hardly remember anything.
Oh yeah, I almost forgot. The brain is responsible for storing memories too. Thanks for reminding me.
But how does it keep all those thoughts and memories safe?
Well, different parts of the brain are responsible for handling different sensory inputs, producing different voluntary and involuntary outputs, and storing memories. Now, if you're asking how the brain can handle being so soft and squishy, it's protected by your hard skull and a layer of fluid inside the skull.
Oh, okay, that makes sense. But I just have one more question.
What's that?
One of my friends told me that after a lot of writing with his right hand, the left side of his head started to hurt. So why the left side?
That's very interesting that you bring that up. It's actually the left side of your brain that's responsible for the right side of your body and vice versa. So if you move your right hand, it's the left side of your brain that's making your hand move.
Wow, I have no idea.
Hey Luigi, you want to play a game with me? Of course I do, Mario, but first I have to finish the episode. You did another episode without me? It's called Lego Luigi Explores the Human Body. Alright, well, can I at least do the outro? Sure. Alright, thanks for watching everybody. Make sure to like and subscribe to Leopard Central for more videos of me and Luigi.
And Pinkles.
And Pinkles. See you next time! Say, where did you get that dry bone shell? Hello, it's me, Luigi, and welcome to Lego Luigi Explores the Human Body. Today, we're gonna look at the circulatory system. That's right. Now, Luigi told me that I have an important role to play in today's episode. I don't know what it is yet, but he said it was important, so I'll keep my ears open. Hey Mario, isn't it time for your daily toad already? Oh, you're right. Thank you for reminding me. I'll try and be back before too long. The circulatory system is our body's own special delivery system, and it consists of the heart, the blood vessels, and the blood itself. With the exception of pulmonary vessels in the lungs, the blood vessels shown in red are arteries, which carry blood away from the heart, and the blue ones are veins, which carry blood back to the heart. In addition to arteries and veins, there are also really small blood vessels called capillaries. These are like bus stops, where the bloodstream picks up and drops off passengers. The passengers could be anything: oxygen, nutrients from the food we eat, waste products, you name it. Hey, didn't you already talk about that in the previous episode? Well, yes, sort of. I did say how blood is mostly water and that it brings liquid waste to the kidneys to be disposed of. Blood is a very major part of the body, so I'll probably talk about it again in future episodes. Oh hey, before I forget, what is it that makes blood red? I'm getting there. I was just about to describe the composition of blood. Ooh, this I've got to hear. The following diagram should clearly illustrate the basic composition of your blood. Around 45% of it is erythrocytes, more commonly known as red blood cells. A mature red blood cell is usually disc-shaped as it has no nucleus. Red blood cells carry oxygen from the lungs to the rest of the body, and then they carry carbon dioxide back to the lungs. The hemoglobin in red blood cells is what makes your oxygenated blood red. When it's in your veins and pulmonary arteries, your blood is dark red, but it turns bright red when you bleed because of the oxygen in the air. The yellowish part you see is plasma, which makes up about 55% of blood. As we mentioned in the episode about the urinary system, plasma is the liquid part of our blood, and it's mostly made of water. The rest of it is stuff that's dissolved in the water, such as proteins, hormones, electrolytes, and waste products. Like urea? Exactly. But what about that whitish part in the middle? That's the Buffy coat. It's made up of white blood cells and platelets. White blood cells keep you healthy by fighting infectious germs, and platelets are broken up pieces of cells that form clots to stop you from bleeding. The Buffy coat makes up less than 1% of your blood. Good to know. Well, I've got to go now. Bye. Let's talk about blood type now. Your blood type is determined by cell markers called antigens. Your immune system doesn't like it when it sees an antigen it doesn't recognize. Red blood cells have two types of antigens. One of them determines whether you have type O, A, B, or AB blood. Type AB, the universal recipient, has both A and B antigens, while type O, the universal donor, has neither. The other type of antigen determines your blood's Rh factor, that is, whether your blood type is positive or negative. If you have Rh antigens, you're positive, otherwise you're negative. Blood type is important to keep in mind if you're going to give or receive blood. You don't want to introduce foreign antigens into the bloodstream. Hey, wait! Come back! My heart bleeds for you! Well, that was unexpected. Speaking of the heart, let's take a look at it right now. The human heart is divided into 4 chambers, 2 atria and 2 ventricles. Each of the chambers of the heart are separated by valves, and the left and right sides of the heart are divided by the septum. When you hear or feel your heart beating, that's the valves in your heart slamming shut. It's just the same when you check your pulse because your veins have valves in them too. Excuse me, can you help me catch that pinkle that just ran by? Sorry, I can't. I'm busy with an educational video. Okay, thanks anyway. The cycle starts here, in the right ventricle. This heart is shown from the front, so when I say left and right, that would mean your left and your right if this were your own heart. From the right ventricle, deoxygenated blood is given a big pump through the pulmonary arteries to capillaries in the lungs where it drops off carbon dioxide and picks up oxygen to take to the rest of the body. Then the pulmonary veins send oxygenated blood back to the left atrium. After that, pressure changes send the blood to the left ventricle, where it's given another big pump through the largest artery, the aorta, to the rest of the body where your various organs get their share of oxygen and get rid of carbon dioxide. Deoxygenated blood then travels through the veins to the 2 vena cava, which lead to the right atrium, which leads right back into the right ventricle where it started. Hey Luigi, I was just sauntering by when I noticed that you forgot to say 3 things. What are those 3 things I forgot to say? First of all, you forgot to say how much blood we have circulating around our bodies. Of course, the average adult has around 5 liters of blood, while a child has only 3. Okay. Second, if you strung all your blood vessels together, how long would it be? It would be 60,000 miles long. That's long enough to circle the Earth nearly 2.5 times. And third, isn't the heart the strongest muscle in the entire... Oh, Mario, you're back early. Well, I realized I was out of Toad Rally tickets, so I can't do a Toad Rally today. Now, what was the important thing you were going to have me do? I was going to have us compare heart rates, but since you didn't run, I guess we won't be doing that. Ugh, Mario, you scared the shell out of me. I think you mean he scared you out of the shell. Hey, you can compare heart rates with that Koopa. Oh yeah, exercise isn't the only thing that can boost your heart rate. No, you don't need to do that. Take my word for it. My heart's beating pretty fast for a turtle. How can you be a turtle if you were removed from your shell unharmed? Hey, this is an anatomy show, not a zoology show. He's right, you know. When you need more oxygen to power your muscles because you're exercising or stressed, your heart beats faster to get that oxygen to your muscles faster. That's right, Mario. If you need to get somewhere quickly, your heart sends blood to your muscles faster. Oh yeah? Well, there's somewhere I need to get quickly. Where? Out of here! Hey, you forgot your shell! Well, this episode ended on a very weird note. I'll say, whatever. Thanks for watching, everybody. Make sure to like and subscribe to Leopard Central for more videos of me and Bowser's helpers. The links to the research sources for this episode are in the description below. See you next time! You know you can get Toad Rally tickets from the bonus game house, right?
Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the respiratory system.
Luigi, what happened to your voice?
My voice? Oh, there was an accident at Professor Egad's laboratory. One of the helium tanks fell over and sprang a leak. I thought the effects of the helium on my voice would have worn off by now.
Well, you can't do the show like that. We'll have to wait for it to wear off. Sorry about that, everybody. Now let's get going. The respiratory system is what allows us to breathe. The main parts of this body system include the nose, the mouth, the nasal cavity, the larynx, the pharynx, the trachea, the bronchi, the lungs, the diaphragm, and another set of muscles that aren't shown in this diagram because they would cover the lungs. You know, I kinda like your helium voice. Oh, I guess this is the third episode in a row we have a pinkling. So, about all that stuff you were saying, what does it mean? Pardon? You know, all that sciencey stuff you were talking about. Oh, of course. The larynx is sometimes called the voice box, and it houses two vocal cords, which are flaps of membrane that vibrate to let us talk, but we'll talk more about that later. The pharynx is the back part of the throat where the esophagus and the trachea, or windpipe, connect to the mouth. There's a little flap of cartilage in the pharynx called the epiglottis that closes when you swallow to keep food from going into your windpipe. And what about the diagram? You mean the diaphragm? Yeah, whatever you call it. The diaphragm is a set of muscles beneath your lungs that helps you to breathe. Okay, thanks. Hey, would you like some ice cream? No, I'd better not. Okay, bye. You know, sometimes I feel like Pinkles are trying to take over this YouTube channel. Now let's take a look at how breathing works. When you breathe in, your diaphragm and external intercostal muscles contract to create extra space, causing your lungs to expand. Tiny hairs and mucus in your nose trap dust and germs that may be in the air when it begins its journey through the respiratory tract. Plus, it moistens the air to keep your lungs from drying out. The air then travels through the pharynx, followed by the larynx and trachea, which branch off into two bronchi, one bronchus for each lung. Think of this as sort of an upside-down tree, with the trachea being the trunk and the bronchi and smaller bronchioles inside the lungs being branches. Oh, that must be Professor Egad. Hello, sorry about the helium incident. I'd be happy to help you fix the damage, but right now I'm busy working on an educational video about the respiratory system. I'll be there in a few minutes. Hey Luigi! Not now, Mario. First I have to talk about the alveoli. Now think back to the upside down tree. The alveoli are like little blossoms on the ends of the bronchioles. While it's common to think of lungs like little balloons, they're actually spongy inside. The alveoli are tiny air sacs where oxygen is exchanged for carbon dioxide from the blood. When you breathe out, the muscles surrounding your lungs relax, forcing the air out the same way it came in. Only this time it's full of carbon dioxide instead of oxygen. This whole process happens about 19,000 times a day. Luigi, just a moment, Mario, I'm not done yet. But Luigi, no buts, we'll talk later. Okie dokie then. Now, you might be wondering how much oxygen we get from breathing. Well, in 1 minute at rest, you normally breathe around 9.5 liters of air, but only 20% of air is oxygen, while the rest of it is nitrogen, carbon dioxide, and other stuff. So that means you breathe in about 1.9 liters of oxygen per minute. Even so, your body can only absorb 1/6 of that oxygen in 1 minute, yet it's enough to efficiently power metabolism, which just means all of the chemical reactions that take place in the body. This is just when you're at rest. Obviously, you need much more oxygen when you're exercising, so in addition to your heart beating faster, you take more or bigger breaths. Oh, and when you're out of breath after a bout of exercise, your respiratory system is just bringing your oxygen and carbon dioxide levels back to normal. Luigi, I'm so glad I found you. Professor Gad is out cold. That's what I was trying to tell him. Well, why didn't you tell me sooner? Let's go. Okay, you guys go. I'll just stay here and catch my breath. Mario, you keep the audience busy. I'll go see if Egad's okay. So, did I ever tell you about the time that I thought I was allergic to toads? My nose was so stuffy I could hardly breathe. Later, the nurse Toadstool checked me out, and it turned out to just be the common cold. She was able to help me feel better in no time. What's wrong with him? Apparently there are no windows or doors open in the lab when the helium tank exploded. So the helium displaced the oxygen in the air and caused the professor to suffocate. Then why didn't you suffocate? I probably did, but I had a life shroom in my inventory. I guess the lack of oxygen to my brain made me forget about Professor Egad when I escaped. Well, there's only one thing to do. You keep talking while I get to one up. Talking. Have you ever wondered how it works? Well, I can explain everything. It starts in the larynx, or voice box, with the two vocal cords. Normally, these two membrane flaps are opened up, but when they're closed, they vibrate and make a sound when you exhale and air passes through them. The pitch of the sound depends on how fast the vocal cords vibrate. That sound is made loud enough to hear by hollow spaces, or cavities, in the throat, mouth, and nose. These particular cavities are known as resonators. Next, the articulators, the tongue, teeth, lower jaw, and soft palate, turn that sound into words we can understand, like this. Now, some may argue that the lips are also responsible for articulation, but that's not entirely accurate. Okay, here it is. Mario, that's a heart. I know, it's a one-up heart. A what? You know, from Super Mario Land. Oh, well, don't just stand there. Take it to Egad. Okie dokie. Wait a minute. If Egad was out, then who was on the phone earlier? Oh. Hello. Sorry about not listening earlier. I thought you were Professor Egad. Oh, okay. Who was that? It was a butt dial. Is the professor okay now? He's okay, but he needs your help with something in the lab. Okay, thanks for watching everybody. Make sure to like and subscribe to Leopard Central for more videos of me and Mario. Once again, the links to the research sources are in the description below. See you next time! Don't worry, Professor, I'm coming to help! Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the immune system.
Hi, is Dr. Mario in the house?
Yes, but why?
Well, to tell you the truth, I feel a little strange. I'm hoping Dr. Mario can figure out what's wrong with me and how to fix it.
Okay, well, good luck. The immune system is what defends the body from foreign invaders. Hey, what's going on here? Oh, look at that handsome Waluigi. What? How did that get in there? Waluigi, you're ruining my show. Get out of here. Okay, fine, loser. And don't come back. Now, where did I put that immune system slide? Oh, you forgot the pinkle pox. You better stay away from anyone else, or they'll get it too. Oh no, that pinkle gave me the pinkle pox. I better stay away from everyone else until I'm cured. Oh, mamma mia, I was just getting ready to go for a swim in the pool, and now I'm up here talking about the... What am I talking about again? Oh yeah, the immune system. I don't know much about the immune system. Could you give me some cue cards? Thank you. The immune system is made of many different tissues, organs, and cells, all working together to protect you against germs. Well, why do we need protection against germs? I know a little German myself. Next! So I missed. Okay, now it's my turn. So as Wario said, the immune system's job is to protect the body from infectious germs, including viruses and bacteria. Unlike most body systems, the immune system has no one definite structure. Next card. The body's first line of defense is also part of the Integumentary System. I'm talking about your skin. Your skin is an impressive physical barrier that protects the inside of your body from all sorts of things, including germs. That's why you should never pick a scab. The skin underneath still needs some time to heal. In addition to the external physical barrier the skin provides, there are mucous membranes lining the walls of organs that are open to the outside, for example, the respiratory and digestive tracts. Plus, they're packed with all sorts of defensive chemicals, such as a strong acid in the stomach. How am I doing? You're doing great, keep it up. Thank you. Now say something were to happen that causes pathogens, which is just another word for germs, to get past that first line of defense. That's when white blood cells get to work. There are several types of white blood cells. The first to arrive at the scene are phagocytes, which target foreign invaders and basically gulp them down. The remains are sent to T cells to give them information on what to look for. When they find infected cells, they destroy them by using an enzyme that causes apoptosis, or programmed cell death. It knows where to find these infected cells due to an inflammatory response. The reason you get red and feverish is because your blood vessels expand to get white blood cells into the infected site as quickly as possible, and your cells can heal faster at higher temperatures, while viruses and bacteria find it hard to keep multiplying. This is great, don't stop! Then don't interrupt. Meanwhile, B cells are hard at work making antibodies to lock onto foreign antigens and label them for destruction. These antibodies stick around, so you likely won't get the same disease more than once. Well, that was easy. What, Luigi? Where were you? Oh, Lakitu, Mario, Waluigi, and I just went down to the local swimming pool to get rid of our pinklepox. What? You guys went to the swimming pool without me? Well, we had to. It's the only way to get rid of the pinklepox. Too bad, so sad.
We know you would have loved to.
Alright, I think we've heard enough. I guess maybe we all should have gotten the vaccine. Then we wouldn't have all this conundrum. There is no vaccine for the pinklepox. There isn't? Oh, Mario, you're a doctor, right? That's right. Why don't you go and collect some samples of pinklepox so we can make a vaccine? No one's ever gone near pinklepox without catching it themselves. It's a no ordinary disease, you know. Well, why don't you go back to the swimming pool and retrieve the pinklepox you just got rid of? I'm sure it won't harm anyone now. Oh, it's not that simple. Once you get rid of a pinklepox, it chemically reacts with the water in the swimming pool and turns into harmonious oxide. There's no way to change it back. That was a smart idea, though. Most vaccines are made of dead or weakened pathogens. The immune system recognizes them as invaders and tries to fight them off, but it does so very quickly because the vaccine doesn't fight back. The antibodies made in the process help you to prevent getting the real disease. Now, viruses can easily evolve beyond recognition, so it's important to get some vaccines often, like every year or so. That's right, Mario. And don't forget that washing your hands with soap and water can also help you and others to avoid getting sick. You should also cover your mouth when you sneeze or cough. Germs can travel incredibly fast and incredibly far. Well put, Ganna? Yep, that's me. Well, good riddance. I'd love to stay and help with the rest of the episode, but I better get home now and spread the word about pinklepox. See you all at the wedding. Okay, bye. Nice tan, by the way. Wait a minute. How did he know about the wedding? I don't know. I don't remember ever seeing him since I became a shy guy and you gave me the flyers. Besides, I read the Weekly Wario, and it says that he's really a nice guy. So what are the chances of him interfering? Coming from a source like that, I'd say similar to the chances of your brother getting type 2 diabetes. Hey, I told you that in secret. Oh, sorry. I just wanted to point out that if your immune system is too powerful, it could end up attacking some of your own healthy cells and giving you an autoimmune disease. For example, Gianna, your brother's immune system attacked his insulin-producing cells in the pancreas and gave him type 1 diabetes. Oh, TMI, Luigi. Too much immunity. You can say that again. TMI. Too much. Okay, I think we'd better end the episode now. Good idea, Mario. Thanks for watching, everybody. Make sure to like and subscribe to Leopard Central for more videos of me and my friends. As always, the links to the research sources are in the description below. See you next time. I think it's a time to give our kids their checkups. Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the Integumentary System. Oh, Luigi, I'm so glad you're safe. You've got to help me. What's wrong? Well, you see, I was knocked out of my shell, and then this wiggler came along and said, "Your epidermis is showing." I have no idea what my epidermis is or where it is, but I feel so embarrassed. Well, maybe today's episode will help. How? You'll see. The integumentary system has many different functions. Wait, hold it. That's not the integumentary system. That's just a picture of Princess Peach, just like in the last episode you had a picture of Waluigi. Yes, well this time I meant to show this picture. It pretty much shows the integumentary system in its entirety. I can't see anything through all that skin and hair. Don't forget nails. Right, nails. So what parts make up the integumentary system? You just said them all. Alright, let me get this straight. The skin, hair, and nails make up the integumentary system? Correctamundo. And get this. The skin is the largest organ in your entire body. Oh, what does it do? I thought you'd never ask. In the previous episode, we mentioned that skin keeps things out of the body that don't belong, but it does much more than that. Along with the nerve endings that help you feel things, it has blood vessels and sweat glands that help to keep you at a reasonable temperature. It also absorbs sunlight to make vitamin D. Wait, isn't sunlight bad for your skin? Only if you're not careful. We'll go into more detail about that later. Right now, let's take a look at the different layers of our skin. Ogres aren't the only ones with layers. Your skin has layers too. 3 of them to be semi-precise. The layer which you can see is called the epidermis. The epidermis, you say? Yep, that guy you met earlier was just saying that the top layer of your skin is showing. So what are the other 2 layers? The middle layer is called the dermis, and underneath that is the hypodermis. Let's take a closer look at each layer. First, the epidermis. Depending on where it is on your body, the epidermis has 4 or 5 layers of its own. The top layer is the stratum corneum. It's made of dead keratinocytes constantly being shed from your skin. Keratinocytes? What are those? Those are little cells filled with a protein known as keratin that makes your skin waterproof. There are also cells called melanocytes that produce melanin, which gives skin its color. Everyone has about the same number of melanocytes, but they produce different amounts of melanin to give skin different colors. Right below the stratum corneum is the stratum lucidum, which is only present in the thick skin on your palms and the soles of your feet, followed by the stratum granulosum. This layer is made of cells that are still forming keratin. As we move deeper into the epidermis, the cells get younger. The next layer is the stratum spinosum, and the last layer, the stratum basale, is made of cells that are actively dividing and pushing old ones away. Through this process, your epidermis will completely replace itself every 4 to 6 weeks. Wow, how do you remember all the names of those layers? I always find it helpful to use the mnemonic device, "Come, let's get sunburned." Why that? You don't want to get sunburned. I know, it's ironic. This is where melanin comes in. The more melanin you have, the darker your skin is, and the more natural protection you have against ultraviolet rays from the sun or from anywhere else for that matter.
UV light can damage your skin, so it's important to wear sunscreen if you're going to be in the sun at all. Right. Now let's look at the dermis. This is the layer under the epidermis, and it has two sublayers. The upper papillary layer connects the epidermis to the dermis, and it has a bunch of little projections that form unique prints on your thick skin. Fingerprints. Underneath that is the reticular layer, which makes up 80% of the dermis. These two layers are full of nerves and blood vessels, so if you get cut and it hurts or bleeds, you'll know you've gone all the way through the epidermis and into the dermis. It's a pity some people have to deal with it every day. What was that? Nothing. The dermis also contains sweat glands to help you keep cool, and hair follicles where your hair starts growing. Hair and nails work in a similar way to the epidermis of your skin. Oh. Additionally, there are oil glands in your hair follicles that help to keep your skin soft and slow water loss. But if your pores become clogged with oil, you'll get acne. So that's why my friend has pimples. The last layer of your skin, the hypodermis or subcutaneous layer, is mostly fat. It provides insulation and energy storage while also acting as a shock absorber and attaching skin to underlying muscle tissue. And that's pretty much all I have to say about the integumentary system. Gee, I sure am glad we were able to get through all that without any interruptions. You mean like that? Huh?
Hey guys, what's going on over here?
Oh, hello Wiggler. I was just explaining to this beach Koopa about the integumentary system as part of an educational YouTube series. Yeah, according to Luigi, you told me that the outermost layer of my skin is showing.
I was just messing with you when I said that.
Oh, well in that case, your epidermis is showing too.
Oh, I just remembered I have a thing I have to do. Bye.
Thanks for this science lesson, Luigi. I've got to go and find a new show now. See you on the web. Okie dokie. Thanks for watching, everybody. Make sure to like and subscribe to L'Epicentro for more videos of me and anyone else who happens to come by. As always, the links to the research sources are in the description below. See you next time! I'm gonna go check on Mother Daisy.
Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the muscular system. Mamma mia, that was a good workout. What was? There was a toad trapped inside a question mark block, and I had to free him and carry him to the goal. It's not easy to run and dodge enemies while holding what feels like an 80-pound creature above your head. Sometimes I wonder why it's me carrying him and not the other way around. After all, from what I understand, he is stronger than I am. Well, I'm glad you enjoyed it. Why don't you go inside and give your muscles a rest while I talk about them? Okie dokie. The muscular system, as its name suggests, is made of muscles. If there's any function that involves movement, voluntary or involuntary, you can thank the muscular system for that. Oh, hi Luigi. How's the web series going? Oh, I was just getting started on another episode. Oh, great. What is it about this time? This one is about the muscular system. Oh, the muscular system. Well, go on. Alright, so there are 3 types of muscle tissue: skeletal, cardiac, and smooth. Let's take a look at each one. First, skeletal muscle. This is voluntary muscle tissue that attaches to bones to make them move. The cells are long and straight, and they have multiple nuclei and visible striations, which are essentially just stripes. There are around 640 skeletal muscles, and they're what most people think of when they think of muscles. Oh, well usually I think of a certain type of shellfish, but that's not what we're talking about, is it? Why would you think that? I'm just kidding. Oh, okay. Let's keep going then. Next is cardiac muscle. It has striations like skeletal muscle, but you can only find it in the walls of the heart. Unlike skeletal muscle, each cell has only one nucleus, and it works involuntarily to keep your heart beating 24/7 without you having to think about it. Also, notice how the cells aren't arranged as neatly as the skeletal muscle cells. They form sort of a branching structure, which makes it easy to tell cardiac muscle apart from the others. And finally, smooth muscle. This is also involuntary muscle, and it has no striations. The cells are short and tapered at the ends, and they each have one nucleus. Smooth muscle lines the walls of blood vessels and most hollow organs, such as those in the digestive and urinary tracts. What's up with him? I don't know. He must be excited about the new movie coming out in the spring. I've noticed it's becoming popular among his kind. Oh yeah. Well, I've got to go and attend a meeting now. A meeting? What for? I'm the president of Foxy's Cookie Fan Club. I thought you hated Foxy's cookies. Yeah, well, it's more of an anti-fan club. If you want, we can talk more about it later. See ya. Okay, bye-bye. Now let's take a look at the structure of a skeletal muscle. As you can see, a skeletal muscle is made of rope-like units that keep getting smaller and smaller. The smallest unit is called a myofibril. Thousands of myofibrils line up to form muscle fibers, which are your muscle cells. They line up to form fascicles, which line up to form your actual muscles. Each of these units is covered by a sheet of connective tissue to make it sturdier. Hey, Luigi! Where's Mario? Oh, he went inside to give his muscles a rest after rescuing a toad from a question mark block. Do you know how hard it is to dodge enemies and run while carrying someone of your weight above your head? Not really. Do you? No, but I know how important it is to take care of your muscles. Hey, how do muscles even work? I was just about to talk about that. It starts in your brain, which is in charge of everything your body does. The brain sends signals through motor neurons to your muscles, telling them to contract and relax. Muscles often come in pairs because they can't extend by themselves, but one muscle can reverse the movement caused by another. By getting shorter, or contracting, muscles pull on tendons which attach muscles to bones. The pulling force on the bone causes it to move, which is how you can, say, move your hand to bring a puppet to life. What? Never mind. Hey, would you care to tell everyone how toads get so strong? I'm sorry, who? The people at the camera. Oh! Hey there! So how as toads get strong is, we have to stress ourselves, doing tasks that we may find hard, and then they eventually get easier. Right. You see, muscles require a lot of energy to do their thing, and exposing them to stress will damage them just a little bit, but that's okay. That little bit of damage triggers the immune system to come and repair the muscle tissue, making it stronger. Right now, Mario is giving his muscles time to heal by resting, and he's also making sure to eat right. Once he's taken care of that, he'll be back to kick some Koopa in no time. Oh, can I help? Sure, we can all play together. Great, I'll go get my friend Barry too. We'll see you back here. Okie dokie. Thanks for watching, everybody. Make sure to like and subscribe to Muppet Central for more videos of me and my friends. The links to the research sources are in the description as always. See you next time! I wonder what Yoshi's fan club is all about. Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the digestive system. Luigi! What is it, Mario? Mario, slow down. I can't understand a word you're saying. Oh, sorry. So remember what you said about Foxy not being able to make his special cookies? Well, let me guess. It's happened? It happened, Luigi, it happened! Foxy can't make his special cookies. Oh, what are we gonna do? Mario, calm down. I knew this was gonna happen eventually, so I've made preparations. Oh, is that why you got the Halloween stuff out early? Well, good thinking. I just hope they can help Foxy. The digestive system turns food into useful stuff for your body to use. It consists of the main gastrointestinal tract, the mouth, esophagus, stomach, small intestine, and large intestine, plus a few accessory organs, such as the liver, gallbladder, and pancreas. Remember these organs: They're all important. What is it? Huh? No, wait, Luigi, come back. It's just a puppet. Oh no, I scared off the host. And now we have no one to talk about the digestive system. Did someone say they needed help talking about the digestive system? Oh, Yoshi, I'm so glad you're here. Can you stand in for Luigi? Sure, I know a thing or two about the human digestive system. After all, how much different can it be from the Yoshi digestive system? Thank you. Luigi's already covered the organs, so you can explain the process of digestion. Alright, show me the diagram. So the first part of digestion, my personal favorite, occurs in the mouth. I'm guessing those cauliflower-looking parts make saliva. Yeah, they produce saliva to help lubricate food and break it down with this, how do you say this? Enzymes? Enzymes. Oh, enzymes. And I've also heard that people have teeth to crush food. That's right, you're not so bad for a beginner. Aw, thanks, Mario. I think I got it from here. Your tongue helps you to swallow, and when you do, the epiglottis closes to keep that food from going into your windpipe. At least that's what I remember from the Respiratory System episode. Next, the smooth muscle tissue in your esophagus pushes the food down into your stomach. Right, Mario? Right. That's called peristalsis. Okay, now the food is in the stomach where it gets broken down even more. I think Ghana said that there was a strong acid in the stomach. That must be what breaks down the food. If it's as strong as I think it is, then why doesn't the stomach just digest itself? Oh, good question. Stomach acid is very strong, but the stomach is lined with a thick layer of mucus. This keeps your stomach safe from its own stomach acid. Well, that's handy. Oh, by the way, what have you got in that block? No, wait, Yoshi, come back. I meant to scare Foxy, not you. Well, I guess it's just me now. So the stomach has acid to break down food, but it also has a layer of smooth muscle segments to help break down that food as well. After it's in your stomach, the broken down food and acid travel to the small intestine. We call it the small intestine because it's not as wide as the large intestine, but it is much longer. Because it's so long, it needs help from the mesentery to keep it from tangling up and to provide a blood supply. Inside the small intestine, there are tiny microscopic projections called villi, and they have even smaller projections on them called microvilli. The villi absorb nutrients, proteins, fats, and carbohydrates, just to name a few, and then take them to the bloodstream where they can be transported to all of the cells and organs in your body to use. But before they can do that, the nutrients need to be broken down further by enzymes secreted by the liver, gallbladder, and pancreas. The liver also stores extra nutrients for when they're needed. And that's what digestion is all about, taking big things and making them small enough for the body to work with. But it's not over yet. The leftovers still have to make their way through the large intestine, where extra water gets absorbed. There are lots of good bacteria in the large intestine that chemically break down some of what's left over before it reaches its final destination, which Foxy is having a little trouble with. I'll try scaring him one more time, and if it doesn't work, then it's on to plan B. Here's a comedy lesson for you. Why did the banana fall out of the tree? Because it was...
Hey! Come here and give me your liver! One pair of pants later.
Oh, Mario, now look what you've done. Oh, I'm sorry for scaring you. I was trying to scare Foxy so that he could start making his cookies again. Oh, and I think it worked. Foxy, maybe next time you might want to try a little more insoluble fiber in your diet. Mario, that wasn't him. It was me. You scared me, and now you've embarrassed me too. Oh, well, I'm glad to see you're getting enough fiber. I'm leaving. Have a rotten day. I knew I shouldn't have gotten dog food, Belle. Hey, Mario. Have you gotten Foxy back to normal yet? No, I haven't. Scaring him didn't work, and now I'm all out of ideas. Hey, I got an idea. How about some ice cream? Oh, no. I'm not falling for any of your fake pinkle... Well, I was going to say dookies and cream, but I guess that works. Okay. Mamma mia! Woo! Thanks for watching. Make sure to like and subscribe. Woo! See you next time. Mamma mia! Whoa! Mamma mia! Whoa!
Hello, it's me, Luigi, and welcome to Lego Luigi Explores the Human Body. Today, we're gonna look at the skeletal system. Hey Luigi, what's going on? Oh, dry bones. You'll be perfect. Perfect for what? To help with today's episode. Just look at you. You're a skeleton. Who better to help with an episode about the skeletal system? Oh, thank you. No one's ever appreciated me for being like this before. You're welcome. Now let's get started. The skeletal system's main function is to provide support for your body. Without it, you would be nothing but a jellyfish-like blob. And that's all bones, huh? Well, mostly. We'll start by talking about bones, and then move on to the other stuff later. First of all, here's a pop quiz. How many bones are there in the human skeleton? I'm gonna go with around 300. That's right, sort of. Humans are born with around 300 bones, but as they age, some of them fuse together, so a full-grown skeleton has only 206 bones. Hey, what's going on here? You know Halloween was last month, right, Wayne? Get out of here, Waluigi. Okay, bye-bye. So I help to support the body. That's a start. What else do I do? Good question. Some of your bones protect the delicate organs in your body. For example, the cranium, or skull, protects the brain. Yeah, you gotta keep that squishy organ safe somehow. And also, bone marrow is responsible for producing blood cells. Marrow? What's that? That's the stuff in the hollow spaces in your bones. That sounds interesting. Can we see some? Well, first, let's take a look at how bones are classified. Bones can be classified in two different ways. One of them is by location. The axial skeleton consists of the bones in the skull, rib cage, and vertebral column. The appendicular skeleton is made of the bones in your arms and legs, plus the pelvis and shoulder blades. Axial and appendicular. That seems easy to remember. The other way we classify bones is by their shape. Long bones, such as the ones in your arms and fingers, are longer than they are wide. Short bones have roughly the same length and width, and are found in places like your hands and feet. Flat bones, like the ones in the skull, are sort of thin like plates. And finally, there are irregular bones, such as the vertebra and pelvis, that don't quite fit into the other categories. Hey you guys, have you seen Waluigi? Oh yeah, he went that way. Thank you. Wait a minute. A question that I've never thought about just popped into my head. What's that? How can Wario's stubby legs support the weight of his entire body? Ah, well the bones in Wario's legs have a special structure that makes them light enough to move, yet strong enough to withstand his body weight. Just take a look at this. All bones have a similar structure. They have an outer layer of compact cortical bone surrounding an area of spongy bone, which is a bit like a honeycomb. The hollow spaces in your bones make them light, and the trabeculae, which are the tiny bits between those hollow spaces, help the bone to resist stress. The hollow spaces also contain red bone marrow, which is responsible for the production of blood cells. What about that big space in the middle? Oh, that's the medullary cavity. It's only found in long bones, and it contains yellow marrow, which stores energy as fat. You know, all this talk about bones is making me feel like singing my favorite song. What's that? You know, the toe bone's connected to the foot bone's connected to the ankle bone. Oh, that one. Well, no offense, but I don't quite agree with that song. Why not? Do you have a better version? Well, no, but even if I did, it would take 2 hours to complete. Perhaps a better thing to do would be to explain the two most important components of bone matrix. Is calcium one of them? Yep. Calcium minerals make your bones hard, but to make them strong enough to keep them from breaking easily, they also need a protein called collagen. If a bone does break somehow, it can repair itself quite easily because it's got living cells in it. But it usually needs help from a cast or something like that to keep it from moving out of place. Wait, we can't talk about bones without talking about joints. Hey, you're right. Joints are places where two or more bones meet. Some joints, like the ones in your skull, are made of fibrous connective tissue and don't move at all. Some are made of cartilage and only move a tiny little bit. Hold on, what's cartilage? Cartilage is a type of connective tissue that acts like a cushioning between bones. It also forms the prototype of your skeleton before you're born, and it's found in places where bones grow, at least until they stop growing. Oh. Now, last but not least for the joints, there are fully movable ones, such as those in your elbows and your knees. They also have a cartilage cushioning and are connected by ligaments, but the main thing that sets them apart from other joints is that the bones are separated by a cavity filled with a lubricant called synovial fluid. These allow you to move your body. Sounds pretty important. Yep. Oh, by the way, ligaments and tendons are pretty much the same in terms of structure, but the difference is that ligaments connect bones to other bones, and tendons connect bones to muscles. Mario, look what you've done to my co-host. Oh, sorry about that. Good thing dry bones can reassemble themselves easily. Yeah, otherwise we'd have to sing that song that would take us hours to complete. Oh, you mean the one that goes, the distal phalanx is connected to the middle phalanx.
Several song-filled hours later.
Hear the word of the Lord. Wow, I never realized how complex a skeleton was. Reassembling myself just seems like second nature. Yeah, it's pretty amazing, especially those 3 tiny bones in the middle ear that help you to hear. What? No, I didn't eat all the spaghetti. Oh, excuse me. Hello? Oh, you don't say. You don't say. You don't say. Okay, bye-bye. Who was it that? He didn't say. Oh, never mind then. Well, thanks for watching everybody. Make sure to like and subscribe to Leopard Central for more videos of me and the others. Once again, the links to the research sources for this episode are in the description below. See you next time! Seriously, how do Koopas do that? Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the Endocrine System. I said, today we're gonna look at the Endocrine System. Usually this is the part where I get interrupted by someone asking me for help or how things are going. You mean like this? Whoa! Oh, Yana, you startled me. Oh, sorry. I just heard that you are going to do an episode about the Endocrine System, and I figured I could say a little bit more about my brother. Oh, yes, your brother. Wait, isn't he the one with the thing that I was supposed to keep a secret? Yes, but now that this channel's lore has expanded, I figure now would be as good a time as any to tell the world. Well then, let's go! The endocrine system is made up of many different glands that secrete chemical messengers called hormones into the bloodstream. It's similar to the nervous system, but it's also very different. How so? The nervous system uses fast electrochemical signals to get messages to specific body parts. In contrast, the endocrine system is a bit slower and more widespread. Both systems work together to keep your body in balance. Oh. Now let's take a look at each of the endocrine glands and the hormones that they make. We'll start with the hypothalamus and the pituitary gland. They're located at the base of the brain, and they're pretty much in control over the other glands. The pituitary gland is divided into a front part and a back part, both of which are regulated by the hypothalamus. The anterior pituitary gland, anterior means towards the front, makes hormones that stimulate growth and trigger other glands. The posterior pituitary gland, posterior meaning towards the back, stores and secretes hormones made by the hypothalamus that deal with kidney reabsorption and, well, actually, let's save that for the last episode. Luigi, there's only one more episode after this. Moving on. The pineal gland, located elsewhere in the brain, makes melatonin, which helps to regulate the sleep cycle. The thyroid, which sits just under the larynx and in front of the trachea, makes T4 and T3 hormones that deal with metabolism, and it also makes calcitonin, which lowers blood calcium levels, while the 4 parathyroid glands on the back of the thyroid make a hormone that raises blood calcium levels. They work together to keep the amount of calcium in your blood at a reasonable level. Hey, that sounds familiar. Do you also have a sibling with thyroid problems? No, why? Just curious. Next is the thymus, located in the upper chest somewhere between the heart and the sternum. This organ is a site where T cells mature, and it secretes hormones that help with immunity. It's generally most active during childhood, and it breaks down around the time you hit puberty. So you're saying that since I'm an adult now, my thymus isn't working? Basically. That's okay though. Usually you have all the T cells you need around puberty. Oh good, so what's next? Next are the adrenal glands. They sit atop your kidneys and have 2 main parts, the adrenal medulla and the adrenal cortex. The adrenal medulla produces epinephrine and norepinephrine, which are involved in body responses such as the infamous fight-or-flight response. The adrenal cortex secretes hormones that help to regulate different levels of substances in your body. Okay, Ghana, you can take this next one. Really? Okay, you're talking about the pancreas, right? Yep, I know you've been waiting for this one, so go ahead, it's all yours. Oh, thanks, Luigi. My brother's never treated me like this before. Okay, so the pancreas makes insulin, a hormone that helps the glucose sugar in your blood to get to the cells in your body. My brother has diabetes, so his pancreas can't make insulin. Therefore, he has to wear a special pump to get the insulin he needs. Oh, really? I thought he took injections. Well, he used to take injections, but the pump makes it easier. He just has to change his site every 3 days. But your brother can still make glucagon just fine, right? Could you remind me what that is? Glucagon is another hormone secreted by the pancreas. It tells your cells and liver to release more glucose into the bloodstream if there's not enough. Oh, I think he can do that just fine. He does have a special pen just in case, but he's never had to use it. If his blood sugar level does get low, he can treat it with just a quick snack. Hey, speaking of which, I'm getting kinda hungry. Do you know any place where I can get something to eat around here? Well, there's a Resner's just southwest of here. I hear their chicken nuggets are amazing. Okay, thanks. See you later. Lastly, we have the gonads. That may sound like a strange word, but it just means the organs that produce sex hormones. These would be the ovaries in females and the testes in males. The most well-known hormones secreted by these glands are estrogen and testosterone. Most of these hormones are responsible for changes that happen during puberty, but they also play significant roles in reproduction, which we'll go into more detail about in the next episode. The way hormones work is by binding to receptors in target cells, telling them to do something in response. While it's true that some hormones can affect your mood, the real takeaway here is that hormones are a key part of maintaining homeostasis, which is the balance of everything that keeps you alive. Hey, Luigi, turns out that Resner's is closed for remodeling. Oh, sorry about that. That's okay, it's not your fault. Do you know where I can get something else to eat, though? Hey, Luigi, can you do me a favor? Sure, how can I help? Well, baby Mario got lost on the class trip to the museum today. Oh, so you want me to help you find him? No. What I want you to do is to keep an eye on baby Peach, while her mother and I go look for baby Mario. Oh, okay, I can do that. And I can help. Thank you. We'll try and be back before too long. Okie dokie. Thanks for watching, everybody. Make sure to like and subscribe to Leopard Central for more videos of me and my family and friends. The links to the research sources are in the description, as always. See you next time. Come on, let's go get the snack. I get it. Mario, you're back. What took you so long? Well, Peach and I looked around the museum to see if we could find Baby Mario, but instead we found a note from Bowser saying that he'd stolen Baby Mario, so we had to go and rescue him. And is he okay now? Yeah, he's okay. How did things go with you and Baby Peach? Mario, you missed it. Baby Peach did her first poop in the potty. Oh, really? That's wonderful. Peach will be so proud. Yeah, I'm proud of her too. Someday she'll grow up to be just like her mother. Yeah. Oh, by the way, how's the web series going? It's going great. There's only one more system left to cover. I can hardly wait to talk about it. Well, let's see. We've covered the urinary, circulatory, nervous, respiratory, and immune systems. Yeah, and then we did the integumentary, muscular, digestive, skeletal, and endocrine systems. So that means the only one left is... Oh, brother! What? I should get Yoshi for this episode. I'll be right back. You stay here and get everything ready. So, Mario was born with a hot dog as well as a plunger in his hand? Well, I don't know about the plunger part, but yeah, that's what he told me. Yoshi, there you are! I need your help for the last episode of LEGO Luigi Explores the Human Body. You do? What system are you covering this time? Well, we've done all systems except one, and that's the reproductive system. Hold on. You want me, Yoshi, to be in an episode about the human reproductive system? Well, yes. Mario, I can't be in an episode about human reproduction. It's too different from Yoshi reproduction. Everyone's going to get confused. Well, you do want to know what the wiener is, don't you? You mean this thing? I already know what it is. That's not a wiener, it's a hot dog. Potato. You told me yourself that this is a wiener. I did? Yeah. Hey, can we see that footage? Okay, here you go. One wiener on a bun. Enjoy. Oh, thank you. So, this is a wiener. Yeah, that's a wiener. Okay, that is a wiener, but it's not the kind of wiener I meant. Besides, wasn't that just Wario pretending to be me? Oh, you're right. So what's the kind of wiener you meant? Just come along and you'll see. Okay, let's go. Oh, this I've got to see. Hello, it's me, Luigi, and welcome to LEGO Luigi Explores the Human Body. Today, we're gonna look at the reproductive system. Oh, the suspense is killing me. Hey Luigi, I'm here to learn what a wiener is. I'll try not to get in the way. Okay, let's start. And cut. That was a great opening. Thank you. Now, which diagram should we shelf first? The male reproductive system or the female one? Wait a minute. What's going on here? We're doing an episode about the reproductive system, of course. Okay, look, I know we've run out of other body systems, but as the fictional brother of this channel's manager, I just want to say something. You can't do this. What? Why not? Well, this is the system that deals with, how do I say this? Private stuff. It's just not right for a family-friendly channel. Of course it is. It's educational. It teaches people and Yoshis all about how the human body works. What's so unfamily-friendly about that? Okay, I understand you want to teach people and Yoshis about how the body works, but it just can't happen. No, I'm calling off this episode. Goodbye. Wait, Ghana, if I don't do this, then how is everyone gonna know about the reproductive system? Hey, why don't you just tell him this? A man and a woman love each other and start doing stuff, and then a baby is born 9 months later. You know, I couldn't have said it better myself. Yeah, but I still don't know what a wiener is. Hey guys, did I miss anything? Oh, a toad! You'll be perfect. Perfect for what? What's going on here? Isn't it obvious? You're a toad. You have a very distinctive body shape. Yeah, so? We can use your body shape to teach Yoshi what the wiener is. How will you do that? Just watch this. Now, pretend that this is a wiener. That's kinda hard to do since I don't know what a wiener is. Well, this top part is the... what is that, Mario? I can't tell if that's supposed to be the proximal end or the distal end. Let's go ask Peach. She'll know which part is which. Wait, Luigi. First, I have to pee. Oh, that's a problem. How come? Well, I know this castle like I know the back of my hand, and there isn't one single restroom anywhere in the castle. Oh, that is a problem. What are we gonna do? I know. Let's go to Cool Mountain.
A few moments later.
You know, Luigi, this was a very good idea you had, taking me here to a bottomless cliff and giving me a fire flower to keep warm. I do wish I could have had a penguin suit like you, though. Mario, forget about it. Just go. Okay, well, time to take a... What? What? How is he doing that? Well, that's one thing that the wiener does. The urethra runs right through it. And it's shaped like that? Oh, of course! I just should have known it was the penis you meant! So, what else does this so-called penis do? Well, this piece of human anatomy is also very important in human reproduction. If you recall from the episode about the endocrine system, one thing that the gonads do is make hormones that deal with changes that happen during puberty. Another thing that they do is produce sex cells, or gametes, through a process that's similar to body cell production, but also a little different. Sex cells only have half the DNA that regular body cells have, and that's because when they combine, the new cell will have half of the DNA from each parent. What's that got to do with your wiener? In males, testes make sperm, which are the male sex cells. They get nourishment from a sticky white fluid produced by the prostate gland, which sits just under the urinating bladder and surrounds the urethra, which carries sperm out of the body. How about what? Oh, I forgot you're still here. Come on, let's go back to the castle.
More moments later.
Hey guys, how's it going? Oh, hello, Ghana. It's going fine, but I want to have a word with the architect who built this castle. It needs a bathroom. Yeah, Mario had to go all the way to the other side of a painting just to take a leak. Can you imagine that? Well, what was on the other side? Cool Mountain. It's a huge floating island in the sky. And we went there so Mario could do his business off a cliff. Don't worry, they're bottomless. Yeah, then Yoshi wanted to know how it worked, so I told him everything. But Luigi, he still doesn't know how it works for girls. What, urination or reproduction? Reproduction. Are you sure you should tell him? I mean, he already knows everything he wanted to know. Yes, but now I want to know more. Well, okay. But this just stays between the four of us. Oh, a power star! The ovaries produce eggs, which are female sex cells. Eggs are stored in the ovaries until it's time for the menstrual cycle to begin. That starts with an egg entering the uterus through one of the fallopian tubes. The egg attaches to the inside wall of the uterus, which thickens to get ready for the woman to have a baby. I gotta show this to the princess! But then if the egg isn't fertilized, the uterine wall breaks down and leaves the body through the vagina. Hey Peach, look what I found!
I'm on my period!
That was weird. Not as weird as the conversation at Cool Mountain, but weird. This process happens around every month from ages 12 to 52. give or take a few years. Wait a minute, you said something about eggs being fertilized. What does that mean? If an egg is fertilized, that means that the sperm has made it through the egg's membrane. The sperm releases enzymes that weaken the membrane, and once it gets inside, the egg's membrane strengthens to keep any other sperm from getting in. The genetic information of each gamete combines to make the full instructions on building a new human, placenta, umbilical cord, and amniotic sac. And in my case, a plunger. What? How else do you think it could have gotten in the womb with me? Oh, never mind that. A new baby starts out as just one cell, and then it grows, and then it splits, and makes a twin, and then one more. Or is that how plants grow? Yes, but you're on the right track. Thank you. During the first 9 weeks of pregnancy, the developing child is called an embryo, and after that, it's called a fetus. The amniotic sac is filled with fluid and protects the fetus during pregnancy. The placenta takes oxygen and nutrients from the mother and sends them through the umbilical cord to the fetus. The umbilical cord also sends the fetus waste back to the placenta for the mother to get rid of. Your belly button is where your umbilical cord used to be. Well, that explains why I don't have a belly button. Right. So after 9 months of pregnancy, the amniotic sac breaks and the walls of the uterus start contracting. This is what we call labor. Eventually, the contractions get so strong that they push the baby out, along with the umbilical cord and the placenta. The baby starts crying so that it can breathe on its own, and when the umbilical cord gets clipped off and dies, a belly button appears in its place. Mario? Hey bro, are you feeling alright? Yeah, I'm just thinking about how hard it was for Mama Mario with me and that plunger. Hey, do you still have that plunger? I think so. Luigi, do you know where we keep it? Isn't it in the basement behind the shelf that I keep my diary on? Yeah, I think so. Let's go find it. Right behind you, Mario. Okay, on the count of 3, I push, you pull. Alright? 1, 2, 3. Look at that. That takes me back so far. It's beautiful. The plunger that was in Mario's hand when he was born. This was worth eavesdropping on Mario and Luigi for. Yeah. Wait, what? I mean, how do twins develop like Mario and Luigi? Well, that depends on whether you're talking about fraternal twins or identical twins. Fraternal twins, like me and Mario, develop when an ovary releases 2 eggs instead of 1, and they each get fertilized by different sperm, so they each contain different genetic information. Identical twins develop when an embryo splits in 2 and 2 babies form. Because they both come from the same fertilized egg, identical twins have identical genetic information. You know, I think I'm gonna call Mama Mario and tell her how I feel.
Hey, it's me, Mama Mario. It looks like you caught me at a bad time, but that's okay. Just leave a message and I'll be with you real soon, okay? Thank you.
Hello, Mama. It's me, your son, Mario. I just wanted to call to tell you that I love you. Hey, tell her I love her too. And Luigi loves you too. We couldn't ask for a better mother. Oh, by the way, your granddaughter, Baby Peach, did her first poop in the potty today, and we're so proud of her. I hope you're proud of her too. Okay, bye-bye. Well, let that be a lesson to all of you. The stork is a lie. Who are you talking to? Never mind. See you next time. Luigi, there is no next time. We covered all 11 body systems, remember? Oh, you're right. This is a problem, but I think I've got the solution. What's that? The people watching this can just comment below with their video ideas. That's a great plan. Thank you. Again, see you all next time when there's another video. Bye-bye.